Hey, what's up guys? This is Krishna here. Welcome to this exciting Houdini MPM tutorial. In this tutorial, we're going to cover various setups: pin to animation, sand cohesion, E-type, render setup, using animated input for the MPM, pin to animation and sand cohesion combined, and then finally finish it off with spread. As usual, the project files are available on gumroad.com as well as payhip.com. If you'd like to support me, please purchase the project files. The MPM files include both version 1 and version 2 files. I will also include the tutorial files. So, without any further ado, let's jump straight in. Let me check the Houdini version here. So that's 21.0559. Let's create a geo and dive in and drop in a rubber toy. I'm going to set up the camera here as well. And then let me drop in a Boolean union. This will ensure that there are no parts that are going to be separated. Let me show you what I mean. I'm going to drop in an exploded view. And if I show you this here, it comes up like that. That means that these parts are separate. But once I Boolean union, it's just a single solid object. All right. Let's drop in an MPM configure. I want to drop this first because I want to show you that this is how it is usually set up. So you got your source here, which is your MPM, and then a collider connects to the second one, and the MPM container itself goes into the third. And this is mandatory. You need to have this, otherwise it won't work. I'm going to go ahead and delete that, and let me drop in an MPM source, connect that guy there. And it's throwing an error because there's no MPM container at the moment. So I'm going to drop in an MPM container and choose this guy over here. And now it shows up. I'm just going to zoom out on the camera a bit. All right, now let's drop in an MPM solver. So the first one is our MPM source, and the third one is MPM container. And now our first setup is ready. So let's just try and see what happens. So this OpenCL kernel compilation is going to take a bit of time the first time you run it, and then it should be okay. So now it's starting to work. As you can see here, it's a bit hard to see, so I'm going to go ahead and change the viewport background to dark, and also I'm going to remove the ground plane here so it's easier to visualize, but we can see that it's working. But what we want is a water or liquid drop to come from someone. So let me create a sphere, and let's template that and transform this. Let me pull that up a bit and make it a bit smaller. The same thing, MPM source, and then I'm going to merge this one and then connect to here. Obviously it's throwing an error because there's no MPM container. So that's pretty much it. Let's run it now. So that's working beautifully. I'm going to go ahead and get rid of that. Let's try and change the MPM source to let's say water. Despite the fact that the water highly viscous, I don't know why, but if I change the density to 500, it kind of behaves a little bit different, more like water. And I'm also going to introduce surface tension. So now let's see what happens. You see your OpenCL kernel is compiling again. That's because of this change. But if you keep seeing this, despite the fact that the source haven't changed, you might have an issue. So there you go. So the sphere is a different material to this guy here. Okay. So let's try and color these guys. Right. I'm going to add a color here, and I'm going to change it to, let's say, this kind of blue. I'm going to change the color for this one, sort of, I don't know, something like that color. Not too much, but yeah, like that. And notice that I put the color above the MPM source. So if I click on the MPM source itself, the color hasn't transferred. And that is because you need to use that one. Once you do that, it's going to pick up the color. And I'm going to do a sign for this guy. So you can see here, no, that's been picked up. Let's run this guy now. That looks okay now. All right, so what do we want to do next? So let's change the MPM source 1 to sand. And let's try that again. Now you can see it's working, except that this is actually falling apart quite quickly. So what we want to do next is that we want to make sure that the sand here, the rubber toy, stays intact until the liquid drops on it. That's the next step. So let's say that I want to enable something called pin constraint. What that means is, once I enable this, you can see here, and I'll show you why it's coming up, because display pinned to animation guide. If I uncheck that, you won't see that. Once I check that, you can see it. Right, so basically that means that my source is now pinned. So let me run this. Let's see. You can see now the rubber toy isn't going anywhere. It's pinned. Well, we don't want that. We want it to react once the liquid hits. I want to try something else as well. So if I just select, let's say, the bottom half here, press enter, it's pretty self-explanatory that it's only the bottom half it's going to hold. The rest of the part is going to come down. Now, you could use this dynamically inside the solver, not outside the solver. And let me explain why. Let me get rid of this here. You see this source here is currently set to once, okay? Meaning, whenever you're going to start this solver, it's going to pick up this item that is coming in. And after that, it's not. So any dynamic changes you want to make, you're going to have to make it inside the solver. Right, let's get back to what we want. So right now, you can see here, it's currently set to pin constraint. So what if we say, let's add an attribute here, attribute create, and we will say what? And by default, it's going to be 1. Yeah, it's 1. And I want this to be integer because it's only going to be either 0 or 1. And I'm going to copy the same across out of this side, and I'm going to say this is 0. So my incoming sphere has an attribute called wet, the value of 1, while the rubber toy has an attribute, wet, with a value of 0. So we're going to transfer this information across. But before we do that, I want to show you that if I were to drop this guy down a bit, let's say to the side, let's say like that, and I'll change this to 1, which means that when I run this now, on the first frame, this sphere is already touching certain parts. So what I'm also going to do is I'm going to just blast here and just look at the rubber toy. So you can see there's nothing here. But let's see if I can select points. So this orange something, I want to create a group, and we call this liquid, LIQ, smooth enough. And then I'm going to copy the same across and put it here, and I'm going to call this body. And now it's easy for us to separate them. Delete not selected. Now I'm going to run this, and you'll see nothing actually changed. And that is because we're not really doing anything with the attributes. Okay, so I'm going to put in a point variable here, and let's type in an expression. If what is equal to 1. There are 2 equals. That means it's checking. If you just have 1 equal, that means it's writing. If what is equal to 1, then there's no then here. So it's open flower brackets or parentheses. We say I at pin to animation. And this pin to animation attribute is recognized internally by the MPM solver. And I'm going to change this to 0 because it's currently set to 1. And that is coming from, where is this guy? This guy here. That's pin to animation. So let's see what happens here. So if wet is equal to 1, then pin to animation is 0. I mean, you can choose to apply this only to body. You can do that if you want, for sure. It's not showing up for some reason. But anyway, it wouldn't make any difference because you could set it to liquid as well as body, or neither. This will only come into play where wet is 1. And we know that the liquid has an attribute wet, value of 1. Right, let's run this. So nothing is happening. Let's see what's going on. So we can see that the liquid is coming down, but this guy isn't. That's because we are not transferring anything. Okay, so let's do an attribute transfer here. We're going to say connect that guy, and that guy. And we're going to say transfer the wet attribute. Although let's not use the, I want to just a bit, not too much. All right, now we're going to connect that here. So the merge will still have both the liquid and the body. But what we want to do is, instead of bringing in the rubber toy directly from here, now we want to bring it from here after our wet attribute has been transferred. So now let's look at what goes. Invalid group body. Well, that's not true. Sorry, my apologies. This is the other way around. So this is the other way around. So that's your source, and that's your destination, and this is the source. So now we have both. That's why. And now let me enable this, and you'll see that part of the rubber toy is now falling apart. Now we've understood that this actually works outside of the solver. I'm going to put this transformation back to 2 up here and 0. and make that 0.5. So if I now leave that, it's going to have a gap between the two. Now, let me run this guy. You'll see nothing happens to the toy. That's because it's only taking it for the first time. Now you might say, well, let's try and change this to, let's say, continuous. It's a completely different setup. When you change it to continuous, the points are emitted continuously. So you can see here, the number of points are increasing. We don't want that. So you could say, I would say $F equals 1. Oops, this is capital F. Then nothing happens because it's only the first frame it's taking. It's the same pretty much as once. But there is a difference which we'll get to later. In any case, we want to take it back to continuous. This is not working right now because all of the transfers and all that jazz is happening outside. So how can we solve this? All we need to do is do this guy inside of the solver, this attribute transfer. So I'm going to copy that or cut that and go inside and say subsolver. I'm going to connect that and I'm going to paste this guy. And we're also going to need this guy here because that's important. So then we can paste that guy here because we need this. Okay? But we know that both of these are coming in here, right? Into the first input. So we know that. Let me see if I could put an add blast here. So I'm going to separate just the body. I'm going to say this is where you want to transfer the attributes to. So I'm going to connect to that one. And this will be our E. And then I'm going to get this guy here. This will be liquid and connect that one down here. Now, what we have is the same as before, except remember, we've isolated the body and then transferred the red attribute. But here in the out, we only have the body. We don't have the liquid. So we need to merge the liquid back into our stream. Now we have pin to animation to 0. Let's try that again now. It's disappeared. So something's wrong. So we don't want to do that here. And that's basically what the problem is. So I'm going to get rid of that and come out. And then we're going to introduce a pop here. Can I just paste that? No, I can't. So I'm going to paste it here. Just copy that, get out. So I'm going to paste that here. And remember, we don't need to get this wet attribute from somewhere else. It's actually coming from the solver. I'll show you another method at some point where we need to fetch this information. But for now, we're feeding wet attribute directly into pop wrangle. And then we're telling the pop wrangle to do something with that attribute. And then we're finishing up. And let's see if that works. Again, it doesn't work. I'm isolating the body. I'm isolating the, of course, this as well. Now, let's see. I forgot to make the change. Let's see here. Now it's working. And let's just look at the body and see if there's any difference. Yeah, there is a subtle difference. And this comes from the transfer itself. So let's say that I'll want to increase this to R1. I'll say this is 0.05. Give it a bit of a blend. Let's run it again. You see now things are looking much better. Okay. But that's how you basically interact one material with another. This particle separation in MPM container will define the resolution of both of these elements. If you choose not to override using this point separation one up here in every single source have these. You can override them using that checkbox and give it a separate resolution compared to this one. But if you were to check both of these, this will mean nothing. But for now, I'm going to use this guy. And you'll see the resolution changes. It's a bit too much. Right, let me run this. So you can see it's working nicely. But if you look at the ground plane, it's kind of chopped off our rubber toy here. If I look at the collision, you have some options here. You can delete what hits the ground plane or keep it balanced. So what I want to do is I'm just going to reduce the friction a bit because it seems like it's too much, but that's about it. I don't want to change anything else here. There is a surface tension here. I'm going to enable that because I think I forgot that one. So let me just try and run that again. Luckily, it's not compiling the CL corner one more time. So it's ready now. Let me run it. I think that looks pretty good. Let me just try and increase this to make this 1. When I'm just looking at the body, I can't really tell. So whether or not, I mean, I can see it's moving, but I want to transfer color as well so that I can see the blue coming into play. Go ahead and make this to 0.02 just to expedite matters so we can see what we're after. When you use this method, what happens is the pins that are currently set up for your rubber toy, is not going to be unpinned if it doesn't come into contact with the liquid. And that becomes important because sometimes you will have some of those points just hanging in the air. That's what I want to show you right now. I'm going to just go ahead and put this down here, particularly down to here. So let me see. Yeah, that's fine. So I'm going to let it run now. Let's see what happens. So there you go. So you can see now this bit here and this bit here is just going to just sit there. So that's the drawback to this one, but that's pinned to animation.